In this new section, we're going to talk about how to do trigonometric integrals. So in other words, we're going to look at the integration on sine, cosine, and the product of sine and cosine, or the product of tangent and tangent and secant. Of course, this certainly applies to cotangent and cosecant, right? They're pretty much very much related. There's one quick thing I would like to quickly mention, which is the reduction formulas. These are used when you to reduce the powers of trigonometric functions. So now in our note, I also followed the idea to make the note. So you do have to review some useful identities. And let's take a look at the first one, the half angle identities. There are sine and cosine two versions. One is for sine theta square, and the other one is for cosine theta square. And I would like you to look at these two identities this way. So the left hand side is power 2, and the right hand side, the cosine, is power 1. So basically, this is to reduce the power, right? Reduce the power of sine and cosine. And you can use this when this is power 2. If it's power 3, then you don't want to use this one. Okay, this is the first one. The Pythagorean identity, certainly that's should be quickly reviewed. These three, and this the first one is the well-known one. This is well-known. How do you get from the first one to second one? If you, by observation, if you divide both sides by sine x square, let me zoom in. So in other words, if you divide this side by sine x square and this side by sine x square, then you get to this version. If you divide both sides by cosine x square, then you get to the next version. So they're very much equivalent. The very last one is the double angle for sine 2x, which is 2 sine x cosine x. So now let's begin with the first one. The book shows you how to do this one, and then also how to do the sine x to the power 4. Okay, one is even, one is odd. We are gonna I would suggest you take a look at the book examples. Oftentimes reading is a good thing. You can try to read by yourself. So let's look at the strategy here. So the first one, we have an odd power, and when we have odd power, we really cannot use the double angle formula. Half angle formula, because if you can recall, half angle formula right here is power 2. It's even power 2. So you can here we have a power 5. So you cannot use that one. Now here's the trick. We actually did this when we back into Calc 1, the substitution. Actually, this calls for a substitution. So the trick is isolate one cosine x. So the remaining cosine x to the power 4, it can be written as cosine x square, right? Cosine x square and then square for the power 4, cosine x power 4. And this cosine x square is the same as 1 minus sine x square. Okay, and then another square outside. And now this cosine x dx, if you let u be sine x, then this becomes 1 minus u square quantity square. And the du is cosine x dx, so perfectly match. That's a perfect match. So therefore, the integral becomes this new integral in terms of u. And use the binomial formula. This becomes 1 times 2u square plus u square, which is u to the 4th, and du. And this is just a simple application of the from now it's a simple application of the power rule. So then you integrate directly, and at the end you do substitution. So that's the book example. So you really should want to try one by yourself and try a simpler one, which is either cosine x cubed or sine x cubed, either one. Because we did the cosine x to the fifth, so cosine we had some experience with it. How about we quickly do a sine x cubed? So this is it. I'm gonna, when I have odd power, I'm gonna isolate one term, and this guy is actually my so you let u be cosine x. Okay, let u be cosine x. Think of this as your du, therefore your u has to be cosine x. So du will be negative sine x dx. Or in another words, so negative du is sine x dx. I just move the negative sign to the other side. Now I can continue. Sine x is, according to the Pythagorean identity, it's 1 minus cosine x squared. So sine x dx. Oops. Now my substitution begins in this step. U is my cosine, so 1 minus u squared. And sine x dx, this guy is actually negative du. So therefore I have a negative du. Now I just, the negative sign, I kind of swap these two, right? The negative sign multiplying, you have u squared minus 1 du. And at the end, you have 1/3 of u cubed minus u. Don't forget to see it. And then my certainly you want to plug in the u plus a c. So that's it for this particular example.